everybody, I just wanted to send you all a quick video. I took a look at how you all did on yesterday's Khan Academy lesson assignments, and I just wanted to check in with you and share with you a couple of noticings when I was going through everybody's work. So here I have a problem that is solved correctly when you are trying to change a repeating decimal into a fraction. So first off, let's say that the problem has given you the repeating decimal 0.123 repeating. So the bar is over 1, 2, and 3. The first mistake that I saw was that people did not recognize or remember that the bar over those set of digits tells you that all those digits together are being repeated. So 0.123 repeated doesn't mean 0.12 and only the 3 is being repeated. It means 1, 2, and 3 are being repeated together as a sequence. So it becomes 0.123, 123, 123 forever. Okay? So that was one big noticing that I had that kind of messed up your work if you didn't get that correctly in the first place. The next thing I realized was that sometimes people didn't multiply by the correct multiple of 10 when they were doing their work later on. So remember, if there are 3 sets of digits that are being repeated, that means that you're going to have to move the decimal point over 3 times. So 1, 2, and 3 to get to the end of that repeated pattern. So since you're moving it over 1, 2, and 3 times, that means you should have 3 zeros when you are multiplying by a multiple of 10. So it won't be 100x, it'll be 1000x. If you can see, I kind of made that mistake in the beginning myself. So the reason why we do that is so that you have one set of the repeated pattern in front of the decimal point. And so you've separated 2 different sets of the repeated pattern. So 1000x would mean 100, or would equal to 123.123.123 forever repeating. If you only multiply by 100x, that means you would only move it over 1 2 times. So you would have 12.3123. So you want to make it so that the repeated pattern is not separated. Okay? And then you're subtracting just a regular x equals 0.123.123 repeating. The whole purpose of that is to separate one of the sets of the repeating patterns from the rest of them. Because now I would have, when I subtract, I have 123.123 behind this decimal point, which is exactly the same as this one, 123.123 behind that decimal point. So they cancel out when you subtract them. That's how we're trying to get rid of the repeating part. And so when we subtract it, we're just left with 123 minus 0, which is 123. So that's kind of our sneaky algebra way of getting rid of a repeating decimal. Okay? But it's very important that you have what's behind the decimal point matching so you can cancel that out. All right? So then you have 123 on the right-hand side, and 1000 minus x is 999. Then when you divide both sides by 999, you would get 123 over 999, or 123 999ths, if you wanted to say that the most proper way. What you do want to check when you're at the end, and this is the end, you don't have anything else to do, is that you want to check that your denominator is bigger than your numerator, okay? The reason why that should happen is because you have a decimal that you started off with that was less than 1. It had a 0 before the decimal point. It was 123 thousandths repeating, right? Or 0.123 repeating. If there were a 1 in front here or a 2, some kind of whole number, then you should have a mixed number or an improper fraction. But since this is less than 1, this also should be less than 1. Okay? If you've got a bigger number on the top, then that means you did something wrong up here. Okay? Another way you can check is to take out your calculator and put that problem in. 123 999ths is really 123 divided by 999. So if you put that in your calculator to just check, you should get 0.123 repeating. So let's go ahead and try that. And you do. You get 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, all the way until the calculator can't even input the value anymore. Okay? So hopefully that was somehow helpful. Let me know if you have any other questions. Please continue to email me. It's very helpful if you email me your work from your notebook. You can just take a picture of your notebook and send that picture to me so that I can see what your mistakes are and then I can better help you. Okay? Know that when you're at home, you're not alone. Just give me as much information as you can, and hopefully I can help you out before I see you for face-to-face. So thank you very much.